Good morning to all the participants and dignitaries out here. Uh, I've, uh, I welcome you all to this 21 day summer school on recent trends in sustainable livestock and crop production technologies vis-a-vis climate change, which is to be conducted from June 18th to July 8th. And soon we're going to be coming to July 8th. That is the sessions would be ending on July 8th. We are organizing this in collaboration with ICR in IGFRI Regional Research Station Srinagar and JK with Bihar Veterinary College and Bihar Animal Sciences University Patna Bihar in collaboration with National Agricultural Development Corporation Limited Baramla. And today we have the honor and pleasure of having with us Dr. Abdul Shakur Khande with us. Sir is soil scientist at SCOST Kashmir. And the topic chosen by our esteemed guest for deliberation today is prospects and opportunities for sustainable agriculture under changing climatic scenario. Sir, you are audible as well as visible, and your presentation is being shared. The session recording has started, and we have about 50 participants who have joined already, and people are joining in. Please start, sir.
Okay, thank you. Thank you very much. Most welcome, dear participants. My topic is prospects and opportunities of sustainable agriculture under changing climate scenario. So, first of all, as everyone among us is aware of the climate change, so this is the formal definition of this climate change. That is, it's a long-term shifts in temperature and weather patterns of our Earth, or our Earth's atmosphere. So this climate change can be mainly categorized into two types. That is natural climate change, long-term shifts in temperatures and weather patterns due to changes in the Earth's orbit, the energy output of the sun, volcanic activity, the geographic distribution of the Earth's land masses, and other internal or external processes. This is not of concern. Natural climate change is not of concern, but this another type of this climate change, the change which is caused by the human activities, that's known as the anthropogenic climate change, that is a point of concern. There's the long-term shifts in temperatures and weather patterns by human activities, such as burning fossil fuels, coal, oil, and natural gas, deforestation, agriculture practices, and livestock, which release greenhouse gases into the atmosphere. The main greenhouse gases are carbon dioxide, methane, halocarbons, hydrochlorofluorocarbons, or fluorohydrocarbons, and nitrous oxide. So, how these actually greenhouse gases, where from they come? What are the human activities which are responsible for the emission of these greenhouse gases into the atmosphere and the resultant global warming or climate change? Most often we interchange these two things, this global warming and climate change. We can say actually the global warming, it's the global increasing trend of the atmospheric temperature, and this is the trigger of the climate change. That means the pattern of precipitation, the spatial distribution, the temporal distribution of and the quantity and the intensity of the precipitation will change. The pressure scenario in the atmosphere will change, and all other climatic factors, they are basically driven by the temperature. That is, we can say to some extent this global warming is synonymous with the climate change. So then there are different sectors which we humans are involved with and which are responsible for the emission of these greenhouse gases. The sectors are energy, industrial processes, this waste, agriculture, forestry, and land use. How they are, because all of, for example, for the production of energy, there's electricity, we do consume fossil fuels, coal, petroleum products. Then there are the industrial processes. They do emit a large quantity of these greenhouse gases into the atmosphere. Then there is waste, agriculture, especially this rice cultivation, which is the main contributor of methane into the atmosphere, deforestation, and intensive land use. So there are various indices which are just giving us an idea about what is the status of this climate change currently now. As you can see, I'm presenting this chart or this graph. It is depicting the annual greenhouse gas index. It's actually combined warming influence of all long-lived greenhouse gases as a fraction of their influence in 1990. That means, for example, in 1990, if it was 0.8, and for example, 1985, it turns out to be 1. Then in 1995, it turns out to be 1.2. That means relative global warming as compared to that which was present in 1990. The AGGI combines the warming influence of main human-produced greenhouse gases and compares them to conditions in 1990. In 2021, the AGGI hit 1.49, indicating a 49% increase in the warming influence of greenhouse compared to 1990. Beginning with the Industrial Revolution in 1750, it took more than 200 years for this index, that is AGGI, to go from 0 to 1. That means from 1750, it took 200 years for this index to go from 0 to 1, but only another 30 years for it to hit nearly 1.5. That is another additional 50% increase in the AGGI index took only 30 years. Related to pre-industrial times, the atmosphere today absorbs an extra 3.22 watts of energy per square meter of Earth's surface. This is very important, this 3.22 watts of energy per square meter. Actually, you may have come across, most of you, RCP scenarios, the different scenarios which IPCC and other this global warming projecting institutes or simulating institutes, they often use these scenarios, especially IPCC. They use these scenarios, RCP scenarios. Actually, what is, for example, there are different scenarios, 4.5, RCP 4.5, RCP 6, then 8.5. Actually, it indicates the net balance between the coming and the going radiation. Solar radiation that comes to the Earth and the radiation that goes back. There is a net. It may be negative or it may be, but it is mostly positive. So it is actually how much gain, how much energy this incoming and this outgoing. So there is a net positive gain of this solar energy, we can say, and this we can call as radiative forcing, and this we express as, for example, you may have come across, this is actually 3.22. We can say currently we are having a RCP equal to 3.22. Then atmospheric carbon dioxide. This is the trend. You can say, see in 1960 it was 320, and now it is 400, more than 420. Human activities release more carbon dioxide into the atmosphere than natural processes can remove. The global average carbon dioxide set a new record in 2021. It was 414.72 parts per million. Despite the continued economic drag of the COVID-19 pandemic, the increase over 2020 was fifth largest one-year increase in the 63-year record. The ocean has absorbed enough carbon dioxide to lower its pH, resulting in 30% increase of acidity. And as a result of this increase in the acidity of the ocean water, it is turning out to be detrimental to the aquatic life as well. So this is the global average surface temperature. Actually, this is the difference of the surface air temperature from 1901 to 2020 surface air temperature average. That means this chart indicates the difference between the realized temperature and the average which was realized from 1901 to 2000. So you can see Earth's temperature has risen by 0.14 Fahrenheit per decade since 1880. But the rate of warming since 1981 is more than twice that. That is 0.32 degree Fahrenheit per decade. 2021 was the sickest, warmest year on record based on temperature data. Average across land and ocean the 2021 surface temperature was 1.51 warmer than the 20th century average of 57.0 degree Fahrenheit and 1.87 degree Fahrenheit warmer than the pre-industrial period. The 9 years from 2013 through 2021 rank among the 10 warmest years on record. Then you can see the scenario: total fossil fuel carbon dioxide emissions from 2000 to 2020. So most of these emissions, they come from China and from United States, but you can see the yearly increase with respect to India, though the emission is really low, but the yearly increase in the carbon dioxide emission is point of concern. India is ranked fourth among the list of countries most affected by climate change. India emits about 3 gigatons carbon dioxide equivalent of greenhouse gases each year, about 2.5 tons per person. The country emits 7% of the global emissions, despite having 17% of the world population. So we can rejoice on this point that emission is not really very high as compared to the other countries, but the rate of increase in the carbon dioxide emissions is a point of concern. Temperature rises on the Tibetan plateau are causing Himalayan glaciers to retreat, threatening the flow rate of the Ganges, Brahmaputra, Yamuna, and other major rivers. Indus River may run dry in future due to temperature increase. Temperatures in India have risen by 0.7 degree, that is 1.3 degree Fahrenheit, between 1901 and 2018. In May 2022, severe heat wave was recorded in India. The temperature reached 51 degrees centigrade. Climate change makes such heat waves 100 times more likely. Without climate change, heat waves more severe than those occurred in 2010 are expected to arrive one time in 312 years. Now they are expected to occur every 3 years. You can see what is the scenario and what are the projected threats. Around the end of the century, most parts of the India will likely face more and more severe droughts. Severe landslides and floods are projected to become increasingly common in such states as Assam. So now, this is these were the slides. They are presenting this current scenario of climate change all over the globe and especially over India. Now, since we are concerned with the effects of the climate change on agriculture and how we can make our agriculture more resilient, more productive, rather more sustainable under the changing climate scenario, we're just coming to that point. So this is the atmospheric greenhouse gas concentration. When it increases, so it does increase these factors. Temperature may vary. Then with the temperature variation, rainfall variability may be there. Rainfall varies, then flooding, or then if it is high, if it is instant, if it is high intensity, if it is very low, then drought may occur. So these are all things which are related to this temperature variation. So finally, this flooding may result in the erosion, or if this is flooding, if it is flooding, so there may be surface water availability problems, irrigation water availability problems, or if there is erosion, the soil moisture retention, soil infiltration, because due to the erosion, the topmost layer of the soil may get washed or it gets washed. So it will have a deleterious effect on the capacity of the soil to retain the water and to make it available to the plants. If there is decrease or increase in the water, that will have a direct effect on the groundwater recharge also. Finally, all these things they assemble to affect the agriculture production or its yield, which will culminate in the farm income losses or profits and danger or assurances to the food security. So what are the drivers and mechanisms for direct climate change impact on cropping systems? How it affects. For example, if there is increase in temperature, so it will cause the acceleration in the maturity. That means the plant will mature in a lesser time. That means the different developmental stages will not be completed up to the perfection, which will result in the yield penalty. Then increase in mean temperature will result in the shift in suitable growing seasons. It may be, for example, increase in the mean temperature may just increase the crop growing season in high hills, especially under Kashmir conditions. But in the areas where high temperatures are currently the problem, further increase will decrease the growing season. Extreme temperatures, they will reduce the photosynthetic efficiency, will cause leaf loss and crop failure. Heat wave during flowering stage. Flowering stage is the most critical stage for the thermal shock. So it may cause, if the temperature rises above the optimum, for example, in case of rice, if it goes above 32 to 35, so it may cause pollen sterility, leading to reproductive failure and low yields. Elevated carbon dioxide. So much has been talked, much has been reported in the literature about the positive effects of the elevated carbon dioxide, but uh, it will, if it gets elevated from a particular threshold level, it may result in reduction of the nutritional content, of the nutritional value of the crops. The crop produced may contain lower percentage of proteins, iron, and zinc under the elevated carbon dioxide levels. So these are the different scenarios, RCP 4.5 and 8.5, and this is the yield performance of different crops in different agroclimatic agro ecological zones of the India. Almost everywhere you can see that the croppers, they are paying a yield penalty with increase in the temperature, barring rapeseed and mustard, because rapeseed and mustard has some genetic heat tolerance, which makes it, which just gives it an edge over the other crops under the changing climate scenario. So this is again on all the regions, starting from Western Himalayan region up to the Western dry region. Everywhere there are yield penalties. Somewhere it is more, especially in this lower Gangetic Plain region, and somewhere it is still having a positive effect. And in our Kashmir conditions also, we have carried out analysis of the changing climate scenario effect on the yield of different rice varieties. And they have shown that up to 270 under different scenarios, that means RCP 2.6, 4.5, 6, and 8.5, the rice crop will show an increase in the yield, but afterwards it will show a decrease. But in the upper hills, it will continuously just up to 2099, the yield will show an increase. So it depends the current prevailing climatic conditions or a place, and that decides the impact of change in the climate due to increase in temperature. So there are other instances which are depicting the effect of changing climate on the crop production. That is 1 degree centigrade rise in the mean temperature could reduce soybean, groundnut, and potato yields in the range of 3 to 7%. A rise of 2 degrees centigrade in annual temperature and a 7% increase in annual rainfall by 2099 may reduce the productivity of Indian agriculture by 8 to 12%. Changes in the rainfall pattern have been found to significantly affect tea production in Assam. With climate change, the Arabica coffee plantations are likely to lose and may shift to higher altitudes. By 2050, the climate change may reduce India's milk production by 15 million tons. Crossbreeds are more sensitive to climate change or thermal heat stress than their indigenous counterparts. In the trans and upper Gangetic plains of India, the heat stress would cause a loss of milk production worth rupees 24 billion by 2039. An increase in temperature from 31.6 to 37.9 has been reported to decrease feed consumption by 36% and egg production in poultry by 7.5%. An increase in temperature beyond 42 degrees centigrade may cause poultry mortality. So climate change, changing climate is also having adverse impact on the fish population. Climate change may alter the abundance and distribution of marine fish species and their breeding and migration patterns. Negative impact due to changes in zoo and phytoplankton, sea surface temperatures, precipitation changes, seawater acidification, sea surface salinity, and oxygen deficiency. Key commercial species such as hilsa, shad, and Bombay duck are projected to decline dramatically if temperatures continue to rise. The energy harnessed by marine plants and algae, crucial for strong fisheries, has already declined by 20% in the last 60 years in the Western Indian Ocean due to climate change, reducing the nutrient mixing between ocean levels. So these are presenting the impact is really very serious. These are other all India specific impacts highlighted by the 2022 IPCC report. Impact of sea level rise on coastal areas. India is one of the most vulnerable countries to sea level rise. India's 7,516.6 kilometer long coastline will be under threat of submersion, floods, erosion, and dense population. Its houses will also face the music. By the middle of the century, around 3.5 crore people in India could face annual coastal flooding, with 4.5 to 5 crore at risk by the end of the century if emissions are high. Direct damage of sea level rise and river flooding is estimated between $24 billion, that's 181,000 crore rupees, if emissions are cut only about as rapidly as currently promised. That means it is sure that we are just going to lose this much of money because of this sea level rise due to climate change. If emissions are cut only about as rapidly as currently promised, and the economic penalty will be 272,000 crore if emissions are high and ice sheets are unstable. Damage from sea level rise in Mumbai alone could amount up to $162 billion a year by 2050 if emissions continue to rise. Reduced labor capacity. Rising emissions will result in India experiencing intolerable heat conditions. The figure predicted for India is 31 degree, which is extremely dangerous for humans. For reference, a value of 35 degrees centigrade is unsurvivable for more than about 6 hours. Currently, in India, the wet bulb temperatures rarely exceed 31 degrees. Lucknow and Patna are among the cities predicted to reach wet bulb temperatures of 35 degrees at the end of the century if emissions continue to rise. Bhubaneswar, Chennai, Mumbai, Indore, and Ahmedabad are all identified as at risk of reaching wet bulb temperatures of 32 to 34 degrees centigrade with continued emissions. Overall, Assam, Meghalaya, Tripura, West Bengal, Bihar, Jharkhand, Odisha, Chhattisgarh, Uttar Pradesh, Haryana, and Punjab will be the most severely affected. Heat will reduce labor capacity, particularly in agriculture, because strenuous work is needed in agriculture. The country's agriculture labor capacity will fall by 17% if warming continues to 3 degrees centigrade. Then there will be water scarcity. About 40% of the people residing in India will live with water scarcity by 2050, as compared to 33% of the population at present. Both the Ganges and Brahmaputra river basins are likely to see increased flooding as a result of climate change, particularly if the warming exceeds 1.5 degrees centigrade. Ecosystems will also suffer ecological disasters such as that in 1998 coral bleaching event that killed off more than 70% of the corals in the reef ecosystems of Lakshadweep and the Andamans and was brought on by elevated ocean temperatures tied to global warming are also projected to become increasingly common. Around 7 million people, then there is human migration. Around 7 million people are projected to be displaced due to, among other factors, submersion of parts of Mumbai and Chennai, if global temperatures were to rise by a mere 2 degrees centigrade. Villagers in India's northeastern state of Meghalaya are also concerned that rising sea levels will submerge neighboring low-lying Bangladesh, resulting in an influx of refugees into Meghalaya, which has few resources to handle under such a situation. Then all this will have a very severe economic damage. India is economically harmed the most by climate change, with every ton of carbon dioxide emitted globally costing the country around $86, and world emitted 36.4 billion tons of carbon dioxide in 2021. That means for the faults of the other countries, India is forced to pay. Since 1991, India's GDP per capita has already been 16% lower than it would have been without human-caused global warming. If the warming continues unabated, then by 2100, the country's average income could be 92% lower than what it would have been without climate change. India has the world's highest social cost of carbon. A report by the London-based global think tank Overseas Development Institute found that India may lose anywhere around 3 to 10% of its GDP annually by 2100, and its poverty rate may rise by 3.5% in 2040 due to climate change. So, under these conditions, it's a big challenge for the agriculture to survive. So, in order to just brief the different climate smart cultivation options, I have opted to select two crops, that's maize and rice, because the cultivation procedures are different and they represent all other crops so efficiently. So I am just going to deliberate it in detail. Climate smart maize cultivation options. So how can we ensure? Now the question is, how can, under so much of climate change, around so much of global warming, so much of the deleterious effect or the adverse effect of the climate change on every aspect of the agriculture, every aspect of the earth, every aspect of the environment. So we are having a multi-pronged or multi-edged challenge to sustain the agricultural productivity. So we will be just discussing maize and rice. In maize, zero tillage. So zero tillage, in zero tillage, as you know, that we are not going to just disturb. We don't disturb the soil too much. We just put the seeds through the dibblers or through other jab planters or two-wheel tractors, and we just don't disturb the soil, because disturbance of the soil through large scale or whole field cultivation, that increases the oxidation of the organic matter, and that increases the emission of carbon dioxide and other greenhouse effect causing gases, especially nitrous oxide. So zero tillage, in addition to just decreasing the greenhouse gas emission, it increases the infiltration capacity of the soil, that water infiltrates much efficiently into the soil. The water retention characteristics of the soil, they get improved. So organic matter content of the soil, that gets improved. Soil erosion under flash floods or under the flooding conditions, that gets decreased. Second option is our cover crops and mulch. So cover crops, especially under the areas where there is preponderance of heavy rain is, and where their land is slopy, there is more preponderance or more severity of the erosion. So cover crops and mulching will just guard the soil from the beating action of the rain and will prevent it from the erosion. Nitrogen fixing, green manual cover crops. Nitrogen, for example, we can use the nitrogen fixing, this velvet bean or cowpea, these we can use, or sesbania we can use. Then there is diversification in the cropping system. Diversification can be achieved. Diversification in the maize cultivation can be achieved through intercropping or through relay cropping or through rotation. So diversification, it enrich it actually it prevents the depletion of soil nutrients, because when we go for the cultivation of a monocrop, for example maize, the nutrients they get depleted from a particular layer of the soil. But when we alternate maize with, for example, wheat, or especially with the leguminous crops, the nutrient depletion from a particular layer of the soil that is just halted. And in addition to that, there is tremendous this scope for the diversification and checking the disease and pest infestation, because it does break the disease and pest cycle when different crops are just cultivated alternately. So inclusion of legumes in the crop rotation, they are really very good. Forging public-private partnerships to improve seed supply. It is really very important because currently this breeding for the climate, or we can say the climate change smart varieties are being developed by the international and national institutes. But the problem is that those varieties are not just available to the common masses, to the farmers. So there is a need for forging public-private partnership, as CIMIT has been forging the public-private partnership in making the maize seed available, especially to the African countries. For example, the open pollinated maize varieties, they are just having partnership with in open pollinated maize seed cultivation with the NGOs and other NGOs and other public sector undertaking institutes. And for these hybrid varieties, they are just giving it to the public. And in turn, those organizations and those public institutes, they fund the research of these institutes. And for long, it has been a very sustainable way, which ensures quality research vis-a-vis supply of the appropriate seed to the farmers. So switching crop varieties or species, for example, so it is the same thing. That means under the changing climate scenario, we should go for the cultivation of crop varieties which are more climate change resilient. And for example, Nigeria or in African countries, they have switched from maize to the cassava, because cassava has shown better yield and growth performance under the changing climate scenario, especially in the prevailing drought-like conditions. Then shifting planting dates. If we know that current planting or the prevalent planting or the sowing dates, they are exposing the critical stages of a crop to the heat shocks or to flooding. So we can just shift the dates to evade. It is an evasion mechanism. We can evade that thermal shock to the sensitive stage of the crop. So broad bed and furrow method of cultivation, especially this broad bed and furrow method of cultivation, it is practiced in the areas where there are chances of flooding and water and the soil gets inundated. So it increases the water use efficiency. It also improves the drainage, and it has also shown to increase the yield. Then there is integrated pest management. integrated pest management, it is really very important under the changing climate scenario, because with change in the temperature and change in the rather increase in the temperature and increase in the humidity, the crop pest incidence has been severe like never before. So what integrated pest management, it relies on the biological control of the pests, for example, shoot fly or stem borer or armyworm in the maize, and it also modifies the habitat and shelter for the natural predators of these pests. So the IPM push and pull system as adopted, it is worth mentioning. The push and pull system in East Africa, what they are doing, along with the maize, they are growing the napier grass and the desmodium. So the stem borers, they are the voracious pests in the East Africa. When they grow napier or the desmodium around this maize crop, the moth gets attracted to the desmodium, because the desmodium creates some biochemicals, and it sends signals to the moth that whole of the maize is already infested by the moths. It confuses it, so it gets forced to go to the places where there is less competition for space and for nutrients. That means the napier plants are the desmodium plants. And when it lands and just gives out the larva, so they get acidic to the sticky material which is secreted by desmodium or napier. And in this case, it has been very successful, and it can be and it should be replicated over here also. Increasing soil carbon sequestration. So we can increase the soil carbon sequestration through the use of leguminous croppers, through the use of these green manures. But while we use, for example, if we are switching from the conventional cultivation to the use of the green manuring croppers, we should ensure that during first 2-3 years, the green manuring croppers, they should be supplemented with some additional nitrogenous fertilizers, because during the decomposition process of these green manures in the soil, the nitrogen already present in the soil that gets tied up, and the subsequent or the successive plants, they may suffer for the want of the nitrogen. So it is a good option to just it is a good option to increase the nitrogen application under such conditions. Then there is agroforestry. Agroforestry is also a crop diversification strategy. All of this, we can say that 90% of the milk production, 80% of the meat production, 41 to 86% of rice, maize, or wheat, that comes from the livestock and crop, I mean to say, this integrated system, agroforestry being an integrated part of that particular system. So it is very important, and we can just try it. Agroforestry systems, especially crops on the peripheries of the field, they protect the soil or the crop from the wind, that just decreases the evapotranspiration losses or the crop losses as well. Need-based and organic fertilizer applications, the reducing greenhouse gas emissions. So this breeding of the climate change, smarter thermal, this temperature, high temperature tolerant varieties, drought tolerant inbreds and hybrids is a very potent strategy with respect to all the crops and with respect to maize as well. So, and these are the registered drought tolerant inbreds, hybrids of maize with NB, PGR, which have been mostly developed by Acharya and G. Ranga Agriculture University. So these are drought tolerant, some are having waterlogging tolerance, some are having the thermal tolerance as well. Especially this, the climate resilient hybrid RCR MS2 developed in 2015 by the University of Agriculture Sciences, Raichur, US. So it is showing a very good promise, and farmers are giving really very good feedback from its cultivation, especially under the adverse conditions of drought-like situations. So after the maize, that means these are the strategies of sustainable crop cultivation with respect to maize, so that we can survive and we can sustain the crop maize yield under the changing climate scenario. So now there is climate smart rice cultivation options. The first is FAO's save and grow approach to sustainable crop production intensification. Save and grow. It is a slogan. It's a slogan which has been raised by FAO to sustain the rice crop production. It involves the resistant varieties, the abiotic citrus resistant varieties, then efficient water use, then integrated pest management, and decrease in the greenhouse gas emissions. Pre-monsoon dry seeding of rice, pre-monsoon. It is coming up as a very good, because all over the world, rice, flooded rice, that is very inefficient with respect to the water use, and that is also responsible for the methane emissions. So people are all over the world, there is an increasing trend of this dry seeding of rice. In India, there is some sort of problem. People are not adopting the dry seeding of rice to the extent to which they should have adopted it, because during the rice season, the soil is already saturated. So wherever possible, these people are adopting the dry seeding of rice, and there are reports that water saving up to 70% is ensured by dry seeding of rice without any significant penalty on the yield. Zero tillage practices are common nowadays in wheat and maize, but zero tillage practices are rare in paddy cultivation, especially where lowland paddy cultivation, where puddling is routinely carried out. So mechanisms or the methodologies have been developed by the area that upland paddy fields, they are prepared. That means citrus are first prepared through two-wheel or four-wheel tractors, and then they are not puddled, then they are irrigated. Citrus, they are irrigated, and water is let to pound over those citrus for 18 to 24 hours. And after that, the planting or seeding is done. And in between the citrus, crops, another croppers, that means crop as intercroppers, they are being grown and they are showing promise. Rice fish farming is really very important with respect to economic aspects and with respect to this climate change mitigation, because pest management, because fishes, they play a very role in the pest management, natural pest management of this paddy, if we incorporate into this rice farming system. They prey on the prominent pests of the rice, that is, snails are there, leaf hoppers are there, plant hoppers are there, and so many other pests. So fishes, they do prey on them, and they also just take care of the weeds, and vis-a-vis they give a economic advantage up to 400%. That means if we are getting 100 rupees from the rice cultivation, so from the rice fish cultivation, we can get up to 400 rupees. So it's 400% increase. Alternate wetting and drying. We get AWD. So it decreases the greenhouse gas emissions from the paddy field is the flooded paddy field is otherwise they emit large quantity of especially methane. Alternating wetting and drying, alternate wetting and drying decrease the greenhouse gas emission. Then this integrated pest management. Integrated pest management, as I have earlier mentioned, that it involves the biological control and stimulation of the natural predators through providing the proper shelter and habitat to them. And this fish farming is really it has been tried in Japan and in China. It is becoming a very efficient component of integrated pest management in rice. Training through farmer field schools. IRI is adopting this farmer field schools, especially to create awareness among the farmers about the integrated pest management. Use of decision support and diagnostic tools. IRI has developed many decision support and diagnostic tools. For example, there is Rice Doctor, which does take care of almost 80 disorders of the problems in the rice. Then there is rice management tool, which has been tried in Philippines, and that's a online tool which gives real-time advisory to the farmers. Then reducing greenhouse gas emissions and sustainable mechanization. So sustainable mechanization, for example, this happy seeder is there, or versatile multi-crop planter is there. Then rice straw management. Rice straw management, rice can't be incorporated, rice straw can't be incorporated because it is very fast, it just degrades very fastly, and it does emit the greenhouse gas emissions. So there are other alternatives for the management of the rice straw, which does give better advantage, around about 20% advantage as compared to the burning. For example, we can use the rice straw as for feed for our livestock. We can use it for the manufacture or production of the biochar. We can use it for just mushroom cultivation, etc. Then crop stable retention, climate small and climate change ready rice breeding. It's very important. That means breeding just it plays a cornerstone role in making our agriculture climate change resilient and sustainable under the climate change scenario. National Rice Research Institute developed CR Dan 801 and CR Dan 802, possessing submergence as well as drought tolerance ability. Sikuba rice varieties developed by IRRI have yield advantages between 1 to 3 tons per hectare over check cultivars after 10 to 15 days of complete submergence under flood water. IRRI scientists identified a major region of the rice genome called a saltol that confers salt tolerance and have developed more than 100 salinity tolerant elite lines. Flood tolerant varieties that have been released through Strasa and are now being planted include Swarna Sub 1 in India and Samba Masuri in Bangladesh. Drought tolerant varieties include Sabhagi Dan in India and Sahud Ulan in Philippines, and the Sukta Dan varieties in Nepal. It is IR 66160-121-442 that inherited cold tolerant genus from Indonesia's tropical Japonica variety, Jimbrug, and northern China's temperate Japonica variety Shannong 89366. In the subtropical Yunnan province of China, a perennial rice cultivar called PR23 has been successfully developed and was released in fall 2018 to farmers in China. So let us come to this very important, especially those participants who are having some experience or who are desirous to use the simulation crop modelers. So these are some modelers which are routinely used in estimating or in predicting or in simulating the climate change effect in terms of the change in the temperature, increase in the temperature, or variation in the precipitation on the yield. There's Epsom, there's Agromet Shell, Aquacrop, Series Wheat, Crop Sister, Daisy, Desat, Epic, Facet, Gilliam, Hermes, and Oriza version 3. So I was rather desirous to give you a hands-on type on this particular model, which I have used it. Said, is technical team listening to me? Is technical team listening to me?
Yes, sir. Yes, sir. We're here, sir.
Help me in just going back and starting the. I want to just hands-on training on this software, simulation software.
Sir, what do you want me to do? How do I help you?
I want to just go back and start another screen. I mean to say.
Press escape or key on your keyboard.
Okay. That's okay.
Minimize or close.
Okay.
Now open anything you want to open as you normally do in your computer, on your computer.
Okay. This is the
Decision support system for agro technology transfer.
okay live, because it may take, but it is just to just expose the participant to how the different sub modules in this particular software, which has been routinely used in studying the climate change effect on the crop.
Is it an open source software? Is it publicly available?
Yes, it is an open source software. All the softwares which I have just depicted or described in my slide, they are open source, and I have given the link also, and I have rather very recently tried each and every link, and they are just working.
And I also see Python and Atom installed on your computer. I think someone does programming in Python.
Yes, I do try at times.
Okay, so you're learning machine learning you're doing?
Yeah, a little bit on my own, everything, sir. Yes, sir. So
I think you should,
I have just
use TensorFlow. I think you should use TensorFlow for machine learning. It's a package provided by Google. If you want to do machine learning, I think you should go get into TensorFlow and Keras. But nonetheless, continue, sir. Please continue.
Yes, sir. So after clicking this is to my dear participants, I want to just say all these projections, for example, under this scenario and under that scenario, RCP 4.5, under RCP 8.5, you may be seeing there is data that yield of wheat will decrease by this percent, and yield of rice will just decrease by this percent, and yield of rapeseed will increase by this percent. And all these projections, they are the work of the simulation tools. You are aware of the fact. So very good software, just routinely used by the agrometeorologists, agronomists, and crop production scientists, I can say. So there are different modules. For example, there's crop management data module, then there is this soil data module, and there is weather data. These are the three important modules. For example, if I want to just create a new crop, just I want to simulate the effect of the climate change on rice. So first of all, I have to just go to the crop management data. I have to click it. So it will self-guide me. There is file. Okay, for example, I'm opening the already this composer file in it. There are different fields. You can see there is file, environment, management, treatment, simulation option is environment. For example, fields. These are the fields. Okay, this is the weather station which we will be making separately, and this is the soil which we will be making separately. Then there's the depth of the soil, then drainage, no need to just write drainage, nothing. Then another initial conditions, what are the initial conditions, previous crop. Then this you can see soil analysis results. Yes, you can keep it as such because we have to incorporate soil separately into this. And there are the management cultivars, which cultivars we are using. You can add the cultivar, for example, Over here you can add, or you can even delete the cultivar. It is your choice. Are you sure to delete it? Yes. Then there are irrigation. If we are working on the irrigation, we can just change. Then there is organic amendment, is fertilizer, tillage, harvest, other things. Then treatments. Then treatments, we can just incorporate as many treatments as we can, which we routinely do in our field experiments. The simulation option is from which date we are starting the simulation, especially it is from the planting or sowing date. So then there is this management, environment management, initial conditions, environmental modification. This is very important with respect to the studying the climate change. For example, in the default conditions, if we are just calibrating the effect, if we are studying the effect of usual treatment, the conventional fertilizer or irrigation treatment is not the crop yield, then we have to keep this screen as such. But if we are just going to simulate the effect of the climate change on our crop yield and performance, then we have to just do something additions are done. For example, maximum temperature increase, minimum temperature increase, projected increase under the different scenarios, or precipitation or carbon dioxide or dew point temperature, or whatsoever data is available with you, which you want to incorporate this environmental modification. That means you can modify the currently prevalent environment, so you can just see its effect. So when we go there, then there is another this soil module is there. So it is, we can just go here. We can profile here. There we in the crop module file, submodule file, we went to the file, and there were two options: new or open. Open option was for those files which were already prepared, and new is for those. But under the soil profile, there over here in the soil submodule, we have to go to the profile, then click new, or then edit. For example, let us see the already prepared this. For example, deep silty this. I'm clicking it, and it is seeing these are the codes. These are the names which are to be written in this. Then next. This is the silt, that means texture information, organic carbon, then pH information. Then these are the other. This you may be caught in a dilemma how to incorporate this lower limit, drainage, upper limit, saturation, water content, as I was during my PhDs. But it by default it calculates if we incorporate the clay, silt, organic material in the previous, say slide into the soil module. Then weather data, it is very important, and how to just incorporate the weather data. For example, let's make a new station, create a blank station. There are options when we click the new station, different options they get highlighted. Create blank station, input import raw weather data. For example, import raw weather data. It is here. Where from, for example, I'm importing like this. Then there are these red and black crosses. I have to right click on them. They highlight what it is actually. It is the date. Then okay, I have given it this date. Then another one, for example, okay, I'm giving the date. For example, right click and I'm giving date. I'm saying it okay, it's date. Then it is, for example, it is minimum temperature. I'm giving, for example, I'm giving it minimum temperature to it. Okay. Then this is maximum temperature. I'm giving maximum temperature. For example, this maximum temperature. For example, this is rainfall and mm. What is it? Rain. And for example, this is. For example, let us keep it as such because there is 40. It's not sunshine hours. So we want to just, now we had to click this. Yeah, we had to import. It says citation name. For example, it is BCF or anything you can four-letter name you can just find. And it says, okay, save me. I'm saving. It says about information. For example, it is 100. It is longitude, anything you can, it doesn't take because it has limit is 100, for example 76, and okay, I'm saying okay. So my weather station has been created. This is location is BCFR, and for example, this is the observed weather, and this is the character. For example, if I want to take a graph out of it, I can take the graphics as well. I can just change the graphics. There are different options, but it is time doesn't permit to go into those details. So then one is we make these two modules. This first we have to make the soil module, then we have to make the weather module. Afterwards, we have to go into the crop management data, because it does require to incorporate our prepared soil data and the weather data. After everything is complete, very, very important in this is this genetic coefficient calculator. For example, this genetic coefficient calculator. And last night I was just having some hands-on on this wheat. So for example, I selected this. For example, it will say there are no valid treatments. That means the variety which we are going to analyze for the genetic coefficient should have different treatments. For example, I'm selecting this one, I'm saying go. It will say me how many treatments you will select. I say, okay, select all of them, then go. It says, okay, it's minus, then I'm saving. You have already saved. So do you want to overwrite? Yes. So then it says run the genetic calculator. Let me run it. Okay, it's running. Okay, it will take some time. Runs per minute set. Okay. So it will take time. Okay, it takes at times from 15 minutes to 1 hour or 2 hours at times it may take. So then we go to, for example, this. After running this, we go to this file. We say, okay, where is the batch file? There are options. Okay. After this runs, we go to file. Here comes the results. Then we coefficient file, crop cultivar coefficient file gets displayed. There are 5 coefficients, so we can change them manually. For example, I get coefficient number A is 13, B is 14, C is 17, and different values. Then I run the simulation. After calculating these graph coefficients, I run the simulation. For example, I go to this. Okay, where is this data? I go here. It is, for example, cereals. Sorry. I go here. Okay. Say that's me. Then I just run the simulation. So simulation between the observer and the predictive, first we have to calibrate the model, for example, with respect to the plant height or with respect to the grain yield. So if it is within 90%, 95%, this confidence is there. There is not this difference of more than 5%. It's okay. Otherwise, we have to go to the genetic coefficient file. We have to just make minor changes. For example, if it was 13, we have to edit that. We have to make it just 12.5 or 12.8. Then I have to try one by one. I have to try the simulation again. Okay, there was discrepancy of 10%. Now, after the change in this very genetic coefficient, there is change of 8%. Okay, it is working. Let me just decrease it again. So this way, one by one coefficient we can change till we get a perfect simulation, as perfect calibration. First, it is calibrated. One is the calibration results are okay. Then we can say our model is now in a position to simulate anything. Thank you. Thank you very much. Thank you.
Thank you, Dr. Saab,
Uh,
for a very comprehensive and elaborative presentation. You delved on so many aspects of climate smart agriculture, covering the topics like climate change, its causes, and how we can adapt or mitigate this climate change. And you gave a very apt examples of maize and rice crop. What are the various interventions that are required so far as adapting or mitigating this climate change is concerned? And finally, the hands-on exercises on various crop simulation models. I hope that participants really might have enjoyed all this presentation of yours. Already participants are appreciating. If you can see the chat box, they are
Thank you.
appreciating your presentation, sir. And
Thank
I
you.
request all the participants to directly interact with you or to put their queries in the chat box so that
Thank you.
for
Thank you.
further clarification.
Thank you.
Your number also will be shared with the participants. If any, they want some clarifications, they can contact
Thank
you.
you. Thank you. Most welcome. Most welcome. Most welcome. And thank you.
Participants are requested to have interaction with the speaker. Let me check the chat box. You can unshare it and you can see yourself the chat box if there are some queries.
Okay. Okay.
Go to Google Meet and stop presenting.
Okay. Google Meet.
Google in Edge browser. Yes. Edge. Left one.
This one. Okay.
Stop present. Click on it. You have to click on it.
Have to click on
Yes. Click on. Stop presenting.
stop sharing. Okay.
Now you can go to the chat window and see the questions, if there are any.
Okay.
There's a chat window next to the users where it is written 56 at the bottom. Next to
Okay.
that is a chat window. You have to click on it.
Okay.
Participants can directly turn on their microphones. I've turned on their microphones. They can directly ask.
Okay. Okay. This Nikhilesh Barwa. Yes, thank you, sir. Do you think that altering of sowing date of field crops is not necessary to cope up with the climate change scenario? Of course, it is one of the strategies, one of the very, especially if the current, for example, we are sowing this transplanting this rice over here up to 15th of the June. For example, if transplanting of the rice on this particular date exposes the critical stage, that is flowering, to the low night temperatures of the August. For example, if the August night temperature just decreases, so we have to just change the sowing time or the planting time. Same is the case where, for example, in the maize, I have already told you that wherever the current sowing date is, they expose the critical, for example, silking stage to the temperature extremes. So we have to modulate, we have to just change the sowing time to evade the thermal shock or the high temperature, which is very unconducive on that particular critical stage of the crop. Thank you. Thank you. Thank you, Niti Barwa. Thank you, Nikhilesh Barwa. Hanji?
Any other question, participants, they can ask directly. If not, then we can consider the session to be concluded. And on behalf of the participants and on behalf of the organizing committee, we'd want to express our heartfelt gratitude to you, sir, for being with us with an elaborate presentation and a hands-on glimpse of the work you do. Thank you, sir, for being with us.
Thank you, sir. Thank you, sir.
It's a pleasure having you with us, and we look forward to future interactions, sir. Thank you.
Thank you. Thank you, sir. Thank you very much, sir.
Thank you, everyone. Let's join at 2:30 for the next session.